So I think there's enough people here to get started, so I'm going to go ahead and get started. So my name's Kevin Peterson. I'm a graduate student at UC Berkeley working in the PhD program in the Biomimetic Millisystems Lab. And so when I was looking at grad schools, the two that kind of stood out to me were UC Berkeley and, once again, Georgia Tech, which came in second again. And ended up at UC Berkeley because I really loved the research that my professor, who was Ron Fearing, was doing with these biologically inspired robots, because there are a lot more interesting things you can do with the biologically inspired robot because they're much smaller and they're much harder to kind of design and conceive and build. And so when I started getting into this research, there's a lot of constraints on it. You can't use like giant batteries on these. They have tiny little batteries, which means they have tiny little processors. The processor on these robots is a 40 megahertz processor, which is really slow compared to modern computers. And so we have to be really creative about how we build our robots and how we design them so that we don't need a ton of processing power. And so one example of that is that this robot here, which is a 6-legged, 2-winged robot, the reason it has 6 legs is that when it's running, it always has 3 legs on the ground. And having 3 legs on the ground means it's standing on a tripod, which is pretty stable. Tripods are always stable. And so you can think of a 2-legged robot when it's running, or when you're walking, you have to continually balance yourself over one leg, which is really hard for a robot to do, just naturally. And so they usually compensate for that by having a big processor that's saying, oh, I'm tipping this way, I'm tipping this way, all right, go back, go back. And that's how they deal with it with big robots. But with this, since we have 6 legs, which is a principle that kind of was learned from cockroaches and lots of other animals that run, we don't have to worry about that. This one just runs stably no matter what we do with it. And so first thing I will do is show you how this robot runs. So if you want to turn it around, it'll run back this way.
What are the applications? What are you going to do with this robot in the real world?
So the kind of bigger applications are search and rescue or building inspection, kind of any scenario where it's either too small of an area for a human to get to or too dangerous for a human to go in. That's kind of where we're thinking about using these robots. And the reason we do biologically inspired is because if you think about it, animals go everywhere. If you have some place that you don't close the door, animals come in. Cockroaches are everywhere, squirrels are everywhere, lizards are everywhere. They can get over any kind of surface that you can think of, and they're remarkably good at it. And so that's why we study animals as we're building these robots.
What other insects or animals do you guys base your robots on?
So kind of the big ones that we study are cockroaches, geckos, and flies and hummingbirds are the big ones. We're nowhere near the fly scale yet. We haven't gotten that good. Nor has technology gotten that good. We're still using motors. It's just really, really hard to make fake muscles. They don't exist in the style we need. We kind of use cockroaches as far as their movement pattern goes. Hummingbirds are remarkably good. We study them, but we haven't gotten that good at emulating them yet. And so we just kind of take some things we've learned from them. We don't actually copy them as much as we copy a cockroach. So this was the first robot I built. We kind of knew it wasn't going to fly, but we thought once we started talking to a biologist at Berkeley, we kind of learned that a robot that can't quite fly is kind of similar to a bird that couldn't quite fly back when they were evolving. And so we were able to do a study on the evolution of flight using this robot and kind of start answering the question of, well, did animals actually run along the ground and take off, or was it more likely they started jumping out of trees and gliding down? And so one of the papers out there that argued that they could run along the ground and take off said that an animal would need about a 4-time increase in speed from flapping its wings to actually be able to take off. And so one of the arguments against that is that, well, animals just didn't have the leg power to actually run fast enough to take off. And so these biologists said, no, they could flap their wings and go faster, then they could take off. In fact, the wings would speed them up by 4 times. And so we did the experiment. These wings come off of the robot, we'd run it without the wings, we'd run it with the wings, and we saw about a 2x increase in speed, which is not near the 4x that they said they needed. And so we said, okay, well, maybe it couldn't run and take off. Let's see how it does in the air. And it actually does pretty well in the air. And so our argument was that, well, you can do lots of things on the ground to run faster and faster. But if you want to glide in the air, you have to get wings. There's just, you need aerodynamic surfaces. And so maybe it's not wings when you start. Maybe it's just, big webbing in your fingers. But eventually, you're probably going to develop wings if you want to be aerodynamic in the air. And so our argument was that it's more likely you're going to get wings from an aerial reason than from a terrestrial reason. And so after doing that study, since I'm a roboticist, I actually wanted a robot that would fly, not one that just kind of run across the table, which is very cool, but it doesn't fly. So I started developing this guy, which is a two-legged, four-winged robot. And so I told you about this one needing 6 legs to be stable. Well, it turns out that the wings actually make this one pretty stable, and it make it more stable than without the wings. And so when I was designing this one, I thought, well, maybe the wings give it enough stability, and so it doesn't need those 6 legs. Maybe 2 legs is enough. And so, which also, helped make it much lighter and actually able to fly. And so let me show you guys how this one works. All right. And so this is my running flying robot called, the name of it's Bolt, which stands for the bipedal, for the 2 legs, ornithopter, because it's a flapping wing flying animal, for locomotion transitioning, because it transitions from running to flying. And I came up with Bolt before I came up with what it stood for, because I just thought Bolt was a cool name.
What do the double wings do? Like, why is
So
two on each side?
the double wings give you a lot more thrust than the single wing does. And so if you look at how birds or hummingbirds or any sort of, mostly hummingbirds and insects, how they fly and how they manage to hover, is they have this wing motion that does this, right? And so they have this complicated twisting of the wing at each end that's pretty hard to do on an actual robot. And so that's how they get the downward thrust on both the upstroke and the downstroke. This robot, since it does have flexible wings, it kind of does that because the wings naturally flex up when they're flapping down and then flex down when they're flapping up. And so it gives you a little bit of that, but it's not as good. With this robot, since it's got the double wing, basically when you are opening, it's kind of like 2 normal wings. They're opening and pretty normal. When they're closing, it's almost like a pump that shoots air out of the back. It gives you a lot more thrust than it would otherwise. And so there's no animals that I know of that have this type of wing design. Dragonflies have 4 wings, but they're not one on top of the other. There's 2 in the front and 2 in the back. And so this is very much an engineering solution. And even though we do biologically inspired robots, if we find an engineering solution that's better, we use it. And so I have an undergraduate student that's working with me to put steering on this robot. And one of the things he might try is just putting a propeller on the back of it. And I don't know any birds that have propellers, but it's a great solution from an engineering standpoint, and so we're going to use it. So.